Oh, hello. Which one? Yeah, still on the majority. There is updated. There is updated. I can share with you. Oh, really? Okay. Yeah, just. Hmm. Does it work now? Okay. Yeah. Yeah, it's good. So this is the first. Is a copper guns. This is the result to the water. Result of the water. We apply this copper guns. And now we could see that 24% reductions from the first container, which is called, yeah, this is the copper one, CU1. And this is the copper gun screen. We wrote it down yeah, screen, yeah. Cesium 134 is totally gone. Is has Yeah, reduced 24%. I calculated. Yeah, originally has a 21 points. No. Yeah, only this one, 21. Mm-hmm. Yeah, this is the result of this copper. And also, have I show you the wire? Yeah. No. Okay, so the wire is the same. It's the wire one. And yeah, to here, I could see also 28% reduction. I calculated from yeah, from the wire. The first wire, we got the some slip. Yeah, 21.71 to 15.73. This is the limitation. It's a limited amount they can detect. I mean, this is the maximum. This gram. It's mean this is a limited amount of detector, limited amount of the yeah becquerel. Yeah. CO2 water is the no, it's still growing. So what I could get is so far is copper and the white. Yeah. So I think all the other results. Mhm, mhm, mhm. Yeah. The last one. You mean the pure one? Okay. This is the wire one, and this is the copper last one. Final results.
copper is more because
This is what this is copper. They both has 28% reduction and 24%. Yeah. Mhm. Yeah. No, I calculate. Mhm. Yeah. Okay. But this has a different amount. That's the original. Mhm. Wire is 15 points. Mhm. CO2 is still. Copper oxide is. Mhm. Okay. So I. Mhm. 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 Sorry, something wrong. The connection is very bad. So could you repeat it? Hello. Uh-huh. Sorry, I couldn't get the beginning part. So could you repeat it again, please? Thank you. Mhm. So, oh, mm-hmm, mm-hmm, okay, mm-hmm, okay, 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 mm-hmm. Also, it's really bad connection. Sorry. One, yeah, okay, okay. So I will get back to you as soon as we finish the CO2 measurement. Then CO2. Okay. Mm-hmm. Yeah. Mm-hmm. 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 Yeah. Those and so yeah. Mm-hmm. Mm-hmm. So yeah. Mm-hmm. Oh. Mm-hmm. See you number two. No, this is number one. See, number one. Yeah, number one. Mm-hmm. Okay. Okay. Mm-hmm. Mm-hmm. Yeah. Mm-hmm. Mm-hmm. Okay. Mm-hmm. Okay. Mm-hmm. Okay. Mm-hmm. 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 Okay. Yeah. Okay. Yeah. I will. Yeah. Confirm. Yeah. Okay. Mm-hmm. Okay. Mm-hmm. I think there is another 5 or 6 containers are waiting to be measured. Uh, the CU, including the copper. We also had the two different kind of copper again. We repeated the same process right after. So I will get all the results together in 3 hours. Mm-hmm. Mm-hmm. Okay. Mm-hmm. Okay. Okay. So again, please let us have a time to get the result. I think the CO2 is almost ready, so I'll go and check. Please stay online. Mr. Cash. Here is the result of the CO2. Okay, here is the result of the CO2. This is the original. This is the result. Cesium CO2. Yeah. Drinking water is no still 12.76. No, no, no. This is the first container. The drinking water is coming. Yeah, yeah. Mm-hmm. Sorry, it's a very slow process here because of only one detector. Should I go back after we could? Yeah. Mm-hmm. It's my words and then all the. Oh, thank you. Thank you. Mm-hmm. 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 Yeah, yeah. I think it's a gigantic step. Yeah. Mm-hmm. 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 Oh, now we have a result of yeah, but this is diluted with this, so yeah, both are. Mm-hmm. Mm-hmm. Yeah. Okay. Yeah. Water. Yeah. Yeah. So for the next result is coming up. Mm-hmm. Okay. Should I call you again when I get result? Okay. Okay. Is it still live streaming now? Or oh dear. Okay. Okay. sorry. This is, we're still waiting for the result, but there is one thing I would like to ask your idea. This is from the people from Fukushima. He would like to do the experiment. He would like to ask you the solution for this water, but a lot of weed inside. This is extracted from the same pool. Do you think is there any solution for that? Yeah, this is from the fire station, but this is the sediment, mostly sediment. You can see just on, the water on this. Yeah, very little, but mostly it's some weed. But actually try to use the one of the they actually measure it also. They actually measure this measure this. Yeah, 394. This is the this they use a different system for the measuring this time. So it's cesium 137, 394. Cesium 134 is 100. Yeah, that's the things. Yeah, this is what I wanted to share with you. So it's 30. Yeah. Yeah. Okay. 安倍さん、お聞きして。OK。ここ、
カリウム
40が、あるんですけど、
はい、
これはこのマシンだから、表示される。
そうですね。ちょっと精度が、違うので、カリウム40もあります。
カリウム40は、ちなみに、頻繁に、どの、要は水の状態でも、食品でも、どこにでも。
そうですね。これは天然の放射線隠しなので、さまざまな物質が入っています。
その土の、あっちの検体でも、これ、同じように出る。
ですね、セシウム以外のもので出たときは、ここのラインに
出るんですね。
これが一酸化炭素ですから、カリウムはここには出てないですね。
ということなんですね。わかりました。すごく少量だからね。ここに要はカリウム以外で。
ラジウムとかラドン系列の、温泉地なので、ビスマスとか、放射性ママとかっていう。
Okay. Mr. Cash? Yeah. So they even from the different system, if we can see that the varieties. I mean, different kinds of, if they can detect different kind of radioactive. Okay. So this was the first sample. Do you remember? It's just soil. It's very highly contaminated. Yeah, this one also has the potassium 40. But the zinc, they say. Radioactive zinc or radioactive radon. They have a natural hot spring. Yes, BE is BE7. Is cesium 134. Next one cesium 134 again, but I don't know what's the difference between これとこれのcesium 134.
Just a different,
yeah. Yeah, as you said. Yeah, different energy. Yeah, energy levels. Yeah, are the difference.
Yeah.
Okay, then cesium 137
Hmm?
and potassium 40. You also put
This one
the
more.
lines. No, the Hi. Yes. Bigger container, like the one we. This one? No, with lid. Oh, like this. Yeah, this is the measurement container. You can see. Mm-hmm. Mm-hmm. Sorry. Okay. Could you repeat it again from this? Ah, okay. The sample. Mm-hmm. 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 No. Sorry. Okay, let me bring the samples we made it today. So then. Okay. Looks like it, yes, but it's even fancier. This is copper pure water. Yeah, it's a copper cream, we said. And wire 2, wire 1. And the CO2 copper cream now is copper cream is 1 1 copper 2 is this one, the data.
Okay.
Copper cream is 13.59. Mm-hmm. Okay. Wire 1, wire 2. Wire 2 is this one. It's cesium 13715.73. This Mm-hmm. Mm-hmm. Half of what? Half of fire too. Mm-hmm. Copper cream. Copper cream. Mm-hmm. 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 Okay, so need those. Yeah. Mm-hmm. Okay. Mm-hmm. Okay. Okay. I shall bring the CO2.
네, 될까? 오늘
Still under the measurement. And from uh-huh. Yeah. The CO2 drinking water. Okay. Yeah. Mm-hmm. 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 Yeah. Okay. 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 So sorry, that's CO2 clean is still in the system, so we're waiting for that, and then. Mm-hmm, mm-hmm. It's in the system, inside of the system now. Yeah. Mm-hmm, mm-hmm. Okay. Mm-hmm. Wire. Mm-hmm, mm-hmm. Yeah. Yeah. Mm-hmm. Okay. So there is a two left today. Yeah. Okay. So please waiting for the CO2. So it, yeah, two different kind of CO2 is coming. So, Mr. Kesh, so while we're waiting for the CO2, do you think is there anything they can try at this moment for this? Mm-hmm. Okay. Mm-hmm. Okay. 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 今これでまたちょっと最後、いろいろな今回持ってきた素材、今それぞれ個別にテストさせていただいて、最後見慣れてみて、効果を見て、でそれを見て、これにやってみるべきだっていうのをしてください。はい。
Just go.
Yes, I'm here. I'm still waiting for the CEO. So I think it's because they have the other things to measuring also. So there is a queue. There is a queue for the measuring system. So sorry for this waiting. Should I coming back
No,
with the result and
no, wait,
yeah?
because it's
Thank
long
you.
time.
Sorry.
Wait, it's the number two.
Yes, it's a
So,
lunchtime, isn't it? Yeah. Yeah.
yeah.
Okay. これが今
Ah, there it is. Could have a. Huh? She's up to 8 record. That was. We lost your voice.
It's different device. Keep it now. So in the recording we have only a couple.
That was the reason.
You change the USB set and it's different device. So it was lost. It was recorded from that previous headset, and this is considered another device.
So from now on it's okay with this.
Until now it was bad. Without recorded mic. I didn't know, but please send us message.
It's okay. They don't hear anything we say. It says it. Alex, can you hear us? You can respond on the other channel. 11. Can you hear me now? Can you be heard? Hello? Hello? Yeah? Can you hear me? No? Okay, can we go to your Coco? Apparently we have a problem with the sound. It was very good. Nobody could hear us. We are back again. It wasn't a sabotage, it was me changing microphone. So we are happily back. Conspiracy theory doesn't work this time. Stupidity. Huh?
Depends how we see it.
Yeah, we didn't want you lot to understand what we were doing, but it's good. Next time we have to buy, you know, one of these, what do you call it? Tuning pendulum, because ding dong, yeah, put it there, because this just looks like a picture.
It's always the same rate.
Cash Foundation. This is taking a long time.
So the dynamic reactors could create the same conditions.
Of course. Much easier. Much easier. This is why I'm pushing you in the lab to do it. You got to. size.
Give me
Tomorrow
the
before I
size.
go.
25 inner diameter.
I'll tell you.
If we have to be done. 24 inner diameter would be better. It would be more precise.
Write it down on the
Right
paper.
now,
The standard measure is 25.
Yeah, because their reactor goes on this week. Maybe by Tuesday. The energy reactor is going on because it just needs to be connected to the load. His reactor is ready to go. Yours and
yours.
It's a very small diameter because it's 5 to 6 centimeter.
give me the measurement.
Give me the
I'll
measurement.
give it to
No, the sphere inside is about 5 to 6 centimeters, and it's porcelain. It's completely.
I saw it. The one you
I saw it.
No, but the thing is,
No,
your
but the
flange
thing
is
is,
as big
flange
as your
Or
core.
core.
See, but it's
Well, I have to try it and try to see the reaction.
you're just gonna give me the.
You're just going to give me this.
And also, the firing has to be balanced with 1280 or 1285.
Write down.
Right now,
Give me the material.
give me the material.
By
By
end of this week, early next
this
week,
week,
all the 7, 8
all the
reactors
7,
will be
8
running. Should not be a problem. Yes, we are. Pardon?
Paper is coming now, but this is amazing result. Drinking water is really drinkable.
I know that. We know that. We know that.
Perfectly
That's why I put it drinking water. I knew the result.
Okay.
So
you
that
already-
goes directly to the point. We need what do you call it? We need the data to show how pure it is.
Yeah.
And what I'm looking for is for the CO2 residual. That is more important. The water we knew for a long time.
Okay.
So that can go to TEPCO, and the data can
Yeah.
be given to TEPCO by what you have to do. We talk about it. You have to speak with the people you've done a test with, and with them go to TEPCO in Tokyo with all the documents. And from this side, keep everything, of course, a copy, and what do
Send
you
it
call
to
it?
you PDF.
And
PDF.
I'll approach the Iranian government in respect to, we can approach through governmental officials into offering the technology to Japan too.
Congratulations.
John says to, what do you call it, don't forget to stamp all the papers that to show is certified by them.
Yeah. Okay.
Make sure, keep a full copy. Send us a PDF file immediately, just not to lose anything. You keep a copy and let them keep a copy.
Okay.
Yeah.
Okay. Okay. So the paper is our paper.
We have a major breakthrough in science. It is if the water comes out, and it's been through the same process of showing other things that are still radioactive from the same batch, and you get a real drinking water, we achieved to finish the Fukushima disaster more or less can be wondered out within 6 to 12 months. It costs nothing. It costs less than $1,000 a tank. Producing the CO2, you can do it on a continuous production line. But we have to have the result. It's got to be in black and white to see.
The way to produce it has to be nice.
It just rains in. You can put the system in the tanks themselves and just rains in, it rains in, it cleans out, they take it out. Yeah. Yeah.
All the condition.
You can you freeze the section where it comes out as a picture, take it out on the YouTube, and we put it on, you put a first picture of the contaminated data when we receive the water, and the result is 0. But we gotta see, it gotta be in black and white before we talk. But the point is, if the CO2 residuals are contaminated, and if that is not contaminated, it proves that nano materials are, what do you call it? They create a gas of themselves. The way we make gas out of the salt from the CO2 or copper oxide, the gases make gases of themselves or create an environment for other metals to become gas too. Non-radioactive balance. So in the way in universe, what is radioactive here cannot be radioactive somewhere else if it's in the state of gas.
Yes.
This is we are learning all together as it goes on. Huh?
Yes, the measurement of the results will help us also to understand
Behavior.
what's behind,
Yeah, more and more.
what we don't know yet. We see that there are no radiation, but what became from has become.
You see, with the copper, the water is still shows contamination, but the material shows no contamination. We got to see it with CO2, it repeats the reversal. And the second test we're trying to do to mix everything together, give us an indication like yesterday, if it drops to how. Then the composite nanomaterials are, what do you call it, are perfect for decontamination totally. Do you know what this says, if you think of it? In a space, if you create a composite layers for your shielding, there is no way you ever get detected, you ever get irradiated. Hmm?
You have to not occur to the other part of your.
I'm gonna change something with your reactor. No, we're gonna change something. You close your center core, huh? Your reactor center is closed. The only one left is E1. Or, no, Marco. Marco's, we put copper oxide in Marco's center. Hmm? Yeah, but yours is half a sphere. Yours is a sphere and yours is a sphere. The only one left is Marcos, which is a full sphere. Yeah, but yours, I hold my hand with that one. I just gonna see if we can be safely walking away from it.
You try to become Italian.
Yeah, I'm already, I don't know. No, but if we can do a test we never done before, we make like a ping pong ball. We secure it in the center with totally copper oxide. And we run it. See if it attracts radiation from the other reactors.
If I can find my ceramics, I've got quite a few of them.
Do you want to glaze all of them? We give the whole lot to be glazed and brought back.
Eventually glazed.
Or go over the high temperature.
The best way is high temperature.
Okay, whatever you want. If we, instead of doing it one at a time,
Yes,
we do it as a batch. Put it in my car tomorrow when I go. I give it, and then they come back. I write down what temperature you want on it. They'll find somewhere. They just do the job and we get it back. This is the beautiful way we work here, huh? Every man does his job and the job gets done at the end. How fast can you draw up a paper, Marek, for this? With all the pictures in it, all the data?
You provide the text.
You write the text from what you understand.
Yes.
I'll provide the text for part of it. Yeah, I'll write the knowledge gain part.
But then I get full understanding.
Yeah, but you can do the procedure. What we did. If you do the procedure and the results, I write the knowledge gain and knowledge thoughts. If you can do it, this can be done immediately. But we can do a short, what do you call it? A short paper to be released within the next 24 hours. We release it to, what do you call it?
Scientists.
To scientists. We post it on our own website. But we have to see what this result is. No use jumping up the gun too quick. And Mr. Jose. Mr.
Broadcasting.
I can't get his name. Our American, what do you call it? Intelligence has gone. Where is Harmon? No, but this is huge. If they figure what she says is there, that's why I said to her, write on it, drinking water. We knew the result is there. But if it proves to be correct, the assumptions were totally correct.
Could it be that the GANs attracts the radioactive elements to be back on a magnet? It could be stuck on
Maybe it's a different way to look at it. Maybe it's different. Okay, we used the salt to create the GANs. We used the salt to produce the GANs of the acids after gases. Is it possible that the gases themselves, because they're in balance, convert other matters within the water? Because don't forget, we are using water again in this situation to convert matters, radioactive matters, to a GANs. And a GANs is a balance. That's why I said when the gravitational magnetic field become in balance, we get a GANs.
yeah,
And when you're in balance, you can create radiation.
okay. But you have a system that has a distance of action which is limited. So when you have a magnet and you put some iron with
It covers up to a certain distance.
Such as this.
Yeah, that's why we think it is, but that's a possibility. I mean, we know that because I explained, yeah. But the thing is, you see these channels, which now a lot of things are explained. We saw the channels again in the containers when she was draining. So these channels are made in a magnetic field strength. And if you looked at it, they're all literally the same strength. It means all the gases are of the same material. I think where the break comes is when there is another material in it, or produces another material. Let's see what this comes. If the CO2 solid comes below or between the copper oxide and the iron, or the copper oxide of the, what do you call it, iron? No, actually it should come. It should be somewhere here. We should see it somewhere below 13. So it should be CO2, copper, wire, because that's a composite. We have the cesium-137 is 0 with copper. With the wire is something she told us. Was it 12.76? There she comes.
Sorry for waiting.
Okay, can you explain? It is 0. Yes, it's drinking water. That is absolutely perfect.
This
This,
show,
pardon?
it show there is no
No radiation.
weapon. Yeah.
That is absolutely fantastic. So, the contaminated water with CO2 becomes a drinking water.
Stamp it.
Yeah.
Can you stamp it? He says. Put your fingerprint on it. Okay, that's what is this one? That was
This is
originally when we started.
Yeah.
So there is nothing. This is a proof of total concept and the technology. This is what we said from the beginning. So congratulations.
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 Thank
Now
you.
Japan is safe to drink their own water. And TEPCO can
Yes.
start emptying the
Right.
tanks. Yeah. Bring that back with you, please. Bring all the materials back with you. Don't leave that behind.
Yeah.
Unless we
I will.
negotiate with TEPCO, they can use it themselves. So, more or less, we can say Fukushima is over as a disaster. Huh? But congratulations. Congratulations. Can we look at the data of the residual of CO2, the gel?
Yes. Now it's coming. Yeah.
Yeah, okay. We achieved it, it's done.
Last step, stamping, because they like to stamp. It has to be stamped again.
They ran out of ink. And it's Sunday. The shops are closed. Oh, this is absolutely perfect. Because if you look at the data on the last column, is more or less the same. You see it here. It's about the same strength. 15 or something. Everything else was a different bracket. We achieved what we set out to, and it's done, it's finished. And this material has been sitting here for 4 years. Now I will inform my...
Police didn't confiscate it.
They don't understand it. They only are after one thing. Now I inform my government tomorrow morning of this, that in respect to it's their job to take it up with what do you call it, with the Japanese. But
Who should you people ask for the allowance?
we go in everywhere now. Because these are internal, they can. We'll see what happens. Now we gotta go in different directions. These people can approach TEPCO and show them the result internally, which is much faster. We support the technology from outside. I'll speak to IAEA tomorrow in Geneva, see what they say, and I'll speak to the what do you call it, to people and their officials to see how far we can do. Now we have a proof. It's a different thing than the talk, and it costs nothing. You literally can bring it, but now we're gonna go to the next step of next test. Now let's mix them, and then separately mix them, and then put them together and see if the bottom result is what we're expecting. No, don't think so.
It depends whether the CO2 is still active.
Active, maybe. Yeah, it's possible because you mix CO2, it brings it down. Because yesterday, one came 85 and the wires were 225. When we mixed it, it came to 130. Possible, quite possible. Because the ones in the other containers are not being touched, so possibly CO2. It shows if it can be repeated. Huh?
Another understanding, if it's like a magnet that attracts, you have a saturation level.
No, no.
So you,
It's dynamic because what's attracted it keeps and the other one comes in, huh?
you don't create new gas.
Yes. It's like nano layers. You don't produce new gas, but you produce another material which has different magnetic gravitational field, which that interaction with the other one creates again the same level.
But with lower
Lower level,
level.
yeah, but in respect about itself. But now you have another layer which start with this creates exactly the same again.
But then the propagation would be.
Before it, if that's how the stars keep themselves in the way they are,
Yes, but here we can see
because it's so small.
a certain distance is limited.
Yes, that's why you see those channels. But now you have, now we're going to mix different materials. They create different channels, so they come together. I think if we mix the copper oxide, the CO2 and the wire, we should see a, we should look at the formation first before it goes in testing. See how the magnetic channels set themselves.
Themselves gets to.
Yeah. Or do they mix? If they mix, they can't separate them, means they work as one body. Now they set. It becomes like Earth. It's a composite. Huh?
Yes, but if they keep separated, then there's something else happening because they have reached
We can extend this to do a test when they're mixed. Well, we got to do it anyway. We're going to be done that, and then finally we link them together, and we see still we get the same water level. Or the last final test will be we test the residuals again and the waters again. If the radiation still exists in the last, when we mix the waters and the materials together, we still see residual. We separate them and we see we can last this if doesn't matter how long it takes. Now we achieved what we set out is, because if you go away and try to reset the whole thing, it takes days and days, and these people have seen the results. We are going nearly 10 hours now, and this is what we set out to do. And if it is there officially, because it's done by the Japanese, it's for their nation, it's a gift to their nation. The way we gifted the energy reactors to the Italian, that's a gift to their nation. They couldn't do it. But it's also a huge problem now. That gel at the bottom of the thing, she was scooping. You settle that in the holes, it becomes like a glue.
Yeah.
We gotta ask her when she comes back, when she brings the sample, let her scoop, see if the gel is still gel or is it separated. Was that a temporary effect? Because if it settles, there is no more leakage as well. It stops the leakage process as well. Remind us when she comes. I want to test something with the guy with the rashes on his skin. Yeah. He's gonna die of it anyway. Yeah, that's cancer. That's the beginning of a skin cancer, radiation cancer. We don't put it directly. Huh? You put it on like a cling film, and it does not absorb by the body. You put it next to the body, the same thing as you attracted. Maybe you know these patches you buy for nicotine. You can make patches with like a CO2 in it, and you put on the cancer and you absorb. That's what we do with the reactors anyway. And he says he knows a lot of people there who have this problem. This reminds me of, I said that recently, you know, when the Eastern Bloc opened up, the Americans used to be in Frankfurt Airport, and they wrote on top of the hangars after they opened up, there was no need for American Air Force in Frankfurt Airport, because one runway was military, one was what do you call it, commercial, civilian. When they finished in 1992, whatever, they wrote on there where they used to keep the military aircraft hangars, big letters, mission accomplished, means they got rid of communism. Now we can put the same thing, mission accomplished. No CO2. Huh? What?
No, we're planting
You're planting?
in Caroline.
Planting trees?
It's kind
A bush.
of bush.
Ah. She's busy in the garden. Sunday.
Totally is black.
Topol is black.
The fruit trees.
All been planted in the back yesterday by the gardeners. Yeah, it's gorgeous. We're gonna have a look. We don't have. No, there are about 6 trees, fruit trees planted yesterday. It's in the memory of, or it's a celebration of the institute. We're gonna make it 8, and 2 more will be.
Well,
There's a fig tree. There's a cherry tree.
it is orange or trees like that.
You haven't seen them when you came in last night? When you go out, just pay attention. You will see something nice. I was working till 8 o'clock, 9 o'clock last night doing it. When you go to the car park, just have a look on your side. We have a Sharon fruit, a cherry, a plum,
Yeah.
a fig,
Apricot.
apricot,
No, apricot, no.
a peach. 6 trees were planted. 2 more will be planted this week, next week, and that's for equal to the member of the. They're supposed to bring a wine, which is a sign of Italy, in the vineyard. It's gonna come on the wall.
Yes, but that's not really a tree.
A fruit. And olive, we can plant olive last 2,000 years. There we are, our boss is here.
There we are.
Yes, okay. What is the.
Certified
Can you?
now.
Both 0.
Yeah.
So drinking
Drinking
water and the
in the
material both
pure-
0. This is absolutely fantastic.
So it means that all the radioactive materials are like concealed.
No, the radioactive material, this is what I was expecting, and now we have a confirmation. The radioactive material convert, the matters are still there, but they change into a GANs. The state of gas to a GANs. So if you come closer, the both CO2 residual and CO2 water are both absolutely 0 for 137, 134. This is major breakthrough in the world of science. This is absolutely, because you have a CO2 pure water is the one we added water to be able to measure the residual, and it's 0. Okay, now we want to do 3 more tests.
Okay,
If you-
Mr. Kesha,
Yeah.
I think it's the time is a little bit running today.
Do you want to do it
Okay,
tomorrow morning?
Oh, yeah, tomorrow can we
Yes, no
do-
problem.
continue those sample? Yeah,
Yeah, you staying there tonight?
yeah, tonight, and then
Okay.
so probably I going back to the first experimental place.
Why your fingers
the
are like this?
formation?
You coca. Why your fingers are like this?
Oh, it is from the globes. Yeah, it's from the globes.
It's from the gloves. Okay, no problem. I thought
And,
you had.
please do not worry, because this NPO has the counter, the whole body counter.
Yeah.
So I'm going to check now for my internal exposure, irradiation,
Yeah.
and then I will be very fine.
Okay,
Thank
no problem.
Yeah.
Can you do
Okay.
something? Because we've been up. Don't leave the place. Stay there because this is more important than anything else. We have achieved the results we were looking for. So to conclude, if it's possible, we come together about 7 o'clock tomorrow morning our time, or 8 o'clock, then 3 o'clock. If it's okay with the
Okay.
people, you are there.
And then continue this. Yeah, but I'm not sure. Let me check their schedule first of all, and then please let me confirm that the next step. So
Yes,
we
please.
have
I'll
to
wait.
discuss.
The next step, I want.
Oh, please wait. I will bring the CO2
Yeah.
liquid also.
Yeah.
Okay.
This is exactly what we thought. So we achieved what we set out. CO2 is zero. Whatever it means, the contamination naturally becomes non-radioactive. And because in there is a composition of, we don't see any K40, we don't see any other materials. So
Maybe
has a.
Now we have our 6 different samples
Okay.
like this. 2 CO2. This is has a sediment.
Yeah.
Yeah, but both are
Put
not
the
detect-
sediments together and put the waters together, please. Okay?
Okay. Okay. This is
Yeah,
layer 2.
she's gonna get confused. Just let's stop at the time with her.
Wire. It's a CU clean. So those one.
Okay. We
Okay,
want
now-
tomorrow we want to do 2 tests. We want to do 3 tests and we stop the process. We want half of the waters.
So we
get-
separated, divided to the 2 groups.
Yeah.
Is it correct? Yeah. So
CU
Drink-
clear.
water. Those are the final results from the
Yeah,
each.
okay. We want
Yeah.
half of these in the front in one container and half of the ones in the back in one container. Yeah? And then when we got the measurement, we want to do one test, is that we mix those last 2 experiment materials together and we do a final test. What we
Okay.
did, we started with one material at the beginning and we split it in three different tests. And
Okay.
the last test, we want to bring everything together and do one test again.
Okay.
You understand?
So we will have 3 tests.
Yeah, 3 tests
mean,
left. One half
in
of
tot-
the waters, one
of the
half of
water.
the residuals, and then the last one we bring the 2 halves together and we see what the product is.
Okay.
And I already know what the result is, but we have to say it confirm 100%.
Okay.
Okay?
Okay. From now on, I can prepare the half liquid
Yeah.
mixture sample
Yeah.
and half liquid mixture sample for this also.
Yeah.
So 2 sample is coming. Then I ask them to measure it by tomorrow.
Yeah.
And
And then mix it
yeah,
together.
study-
And mix half of those 2 together.
Together. Okay.
Yeah.
And then
You do
look
half
also-
and half. Yes.
Yeah,
You do
I
half of
understand.
the water and half of the residual together.
Mhm.
And then when they done the measurements, again they take half of each one of the containers of the mixtures and half of the water mixtures, and they do one test. So we have a, what do you call it? We have a sample from all the process all the way through.
Yeah. Okay.
They could take one free.
I think I understand.
You understand? No, it's the
Please.
same.
So yeah, I understand. So I
Half
will
and
bring
half.
the other container to take the half
Yeah.
of each containers now. Okay.
Yeah.
Let me finish this process, and then I can leave the measurement part to them, and then we can start it
And then
from
you
the
take
result.
from what you get half here from the water and from half of the mixture of material, you make
Yeah.
a third one, the final piece, and we want to result for that final piece too.
Okay.
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 Can you tell us
Okay,
where
so
we can start
container
again?
for
Or
the
we
measuring, and then I coming back here to get the result to share
yes,
with
but
you
make
tomorrow.
sure it's done the process. And you not
Yeah,
only the
I,
results,
I no, yeah, I will do
not
it now.
only the
Just leave.
results, the material has to be sealed. Seal the materials.
Okay,
Okay?
okay,
But make sure,
okay.
Yokoko, make sure
Yeah,
all the materials you brought with yourself goes out of there. You don't leave anything behind.
okay.
Okay?
Those
No,
also
those are
include.
contaminated material. They are not yours. Do not.
Okay, okay.
Okay? The only thing I
Okay,
want you to, the only thing you carry is all the materials which come from Italy. You
yeah,
don't leave
okay.
anything behind.
Yeah, I will
Okay?
take it with me.
And the material which carries the CO2 and the material which carries the copper oxide,
CO2.
they yeah should not be left behind. Those are your material. You withdraw them.
Mhm.
Okay?
Okay.
But you
Okay.
get them to stamp everything. One of the best things you can do is seal all these bags and sign it that it cannot be opened.
Ah, okay. Yeah.
Because most probably TEPCO will want them sealed containers. Change all these rubbers to a seal, stamp it or staple it and seal it.
Mhm.
Yeah? That when it
Mhm.
goes to TEPCO, they receive the sealed back, it won't be tampered with. Because I know they tamper with things very easily, yeah?
Mhm.
They put some
Yeah.
more
Yeah.
nuclear material on the way in it to show the system doesn't work.
Mhm.
You understand?
Yeah. Yeah. Yeah.
So just safeguard yourself and please, what do you call it? Can you ask them when they will give us this data? Now?
Ah, okay. How I shall they try to focus it.
Because we want to be live on when the data is out. Now there is 8 o'clock at night. They want to go home. They don't get paid overtime. And they say Japanese work till late. But it's a Sunday today. This is this is a huge breakthrough. This is a gigantic breakthrough. Not only for TEPCO, but for us for space technology. This explains a lot of things in our space technology, how we can use the materials even in construction of the reactors.
Maybe even if we used more CO, not CO gas, we could also clean the water.
Clean what water?
If we had more CO gas mixed in
CU?
contaminated water,
CO2, CO2 or CU?
hydroxide.
Yeah, it's a CU, it's not a hydroxide, it's a CO. It's CO. Maybe, but we did it. We did it with the first materials. Yeah, with the soil. We doubled it, we put in.
But not
The
in water.
Yeah, no, we do. But this is what you gotta do, huh? We got to try more. We did it yesterday with extension, now we did it with extension. Can you take a shot on your system of where she put the two together? We ask her if you can take a screenshot. We ask her.
Maybe it's better to use the PDF so we can send it.
Yeah, but take a screenshot and keep it in case something happens. Yeah. We ask her to show it on and just take a screenshot from here.
It's recorded in
It's recorded in there. Now, maybe in 2 weeks' time, when your systems flies, it'll be the same. I can bet which one flies first. I know. Nah. You see, none of these are put down. On the CO2, I asked her to write, it's written there, drinking water. And it turned out to be drinking water. The rest is still show residual. I know which one of yours work. And I've got a very good idea how much it flies. No.
It has already flown.
Ah, but that's been radioactive material. This is a non-radioactive. Huh? I can be wrong, then it becomes an embarrassment.
No. There is no embarrassment between us.
No, but we knew about CO2 for a long time. We knew about the property of CO2. I know about it nearly 4 years. So
So you already made this list.
what do you think? CO2 we knew. 100% is correct. And you see in the material and the water is both zero. And they come from the same source, the same process, parallel 3. But I know which one of your reactors is going to fly.
So they will
Just bring a chair and a cushion. If you want to be a passenger, bring a cushion and a chair.
And helmet.
No, you fall backwards. But the only thing, one thing, we put a chain and a barbed wire around the tables. Nobody jumps in because I did it. It's stupid. You get so excited, you jump on it, and you damage your reactor.
jump over here.
That's what I did. That's how. No, I sat on it. I wanted to see how it flies. Yeah, it has a frame. It had a frame. Why do you think the reactor down there stinks like? And I showed it to you. Because I got too excited, I cracked it. Are you seeing that reactor? The first reactor. The transparent top. Yeah, because the thing cracked. The structure cracked. You seen the round reactor with the transparent with the motor inside? Just put your nose in and smell it.
Can we build something that you can see it?
Yeah, Marcos.
Frames, I can build
Marcos.
the one that will fly.
We can screw in
Marcos?
some more seats.
Marcos, it has a seat. And the foundation one, the one we brought from for energy, that will fly with it. But there's another one which fly first.
Ivan.
Yeah. We'll see. Italian, I don't know.
I think Ivan.
That's how I cracked the first reactor. It was such an excitement because usually it takes time. That one, the first load, it jumped. So I got excited. I wanted to hold it and I cracked it. And the smell was, and I was online calling, it's flying, it's flying. That's why we made the new one. And that's why with the test, the Iranian space reactor will be on the table. That will fly. The Iranian space reactor will fly. That is not counted. Because we need 2 more. Hello, yes?
So
Yes?
I could come back. I can coming back here to get the results of those last experiment tomorrow at in the morning time.
What time?
So,
I want to be live online when we see the results because we want to record it.
Okay. So please set up. Is it Italian time around, let's say 8 o'clock is it? What time is gonna
Italian
be?
time 8 o'clock is 4 o'clock in the afternoon your time.
Yeah, so I shall probably go to that first experimental place.
You don't need to
In the-
go anymore. Leave it.
Really? Oh,
Yeah, because
okay.
we got the data we were looking for.
Okay.
Oh yes, you have to. Sorry. No.
You have to get every 2 hours measurement results.
Yes,
so,
yes, but something else we forgot there, Yukoko.
Yeah.
Take half of the CO2,
Mhm.
mix it with water, clean water,
Mhm.
and add it to that dried soil. You know, he had a dried soil in a bag.
Yeah, you mean the first experimental place? Yeah.
Yes.
Yeah.
Take a piece of part of that soil
Mhm.
and mix half of the CO2 you carry, because I'm sure TEPCO will want to get their hands on this CO2. We gotta hold as much as we can to it. So you don't have much. You don't have much copper oxide with you either. So take, unless I've got a built system for CO2 to send it to you for TEPCO if they need it. That's too much. It takes at least 2 weeks to produce the system. No, because we want both of the tests yesterday and today were with water mixture and then we washed it. What I want to see is how the farmers can use the system in a dry soil on its own. So you can spray it like a fertilizer and they'll let the land decontaminate on its own. Go back there tomorrow, get a small amount of the material, measure its radiation, and then use a third of your CO2, not all of it, a third of it, yeah? Shake it, and third, first of all, the way to do it is you take a measure of the dry sand or soil you have there, enough that you can mix a third of CO2 in it, that you can stir it. You don't want to wash it, you just want to wet it. Just allow the CO2 to come in touch with the soil as much as possible. That it's like just moist it. Don't get it wet. You don't need to wash it. You understand? And then measure the radioactivity of the soil. That's the only thing you need to do there, and pick up all the measurements from yesterday as well. Okay. I congratulate you. You achieved what you went out for. Now,
Thank you.
this is fantastic news. All to do is you speak to these people tomorrow when we get the final results. I know what the final results will be near enough too. Then you organize with them to approach TEPCO with the data with them.
Okay.
And you keep all the samples sealed. I'll speak to the Iranian government officials on the new, nanotechnology, and the Iranian delegation in Geneva to see how we can take the step further internationally, because now we found the solution. Thank you very much.
Okay. Thank you very much.
Congratulate you. Thank your people there. Without them, we couldn't do it. Thank them very much for their work.
Thank you. It's my
Thank
wish.
you very
Thank
much
you very
indeed.
much.
That was a beautiful move. Thanks indeed. Have a nice evening. Bye-bye.
You too. Thank
Bye,
you.
Yukako. Bye.
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 So where is the champagne?
Oh no, call her back. We forgot.
Hello.
Hi, Yukako. We forgot one thing. Can you put the 2 papers for the CO2 on the screen? We want to take a screenshot.
Yeah.
No, the
So-
paper, the CO2 papers.
Yeah.
Okay, put separately one, or put separately one, you take one, and then we do two together. Yeah?
Yeah.
The CO2 result. Make sure your people there keep a copy. You take a copy, they keep a copy. Okay. One at a time. Do the water here. Can you take a screenshot? Huh? Okay, put it on to the front that we can see. Come down, lower a little bit. Okay. And now the other one, please. That is the, which says pure water. This is the one we added water to CO2 residual, yeah? Okay, and then can you put the two together, please? Okay, because Marco is going to take a screenshot. One is CO2 drinking water. That's perfect, Mark. Thank you very much. Thanks, Yukoko. Thank you. All the best.
Mr.
What?
Christian, should I make a sample now or?
Pardon? Make the
should I
samples
continue?
now because you know what you're doing. Yes, please.
Yeah. Okay.
Okay. Make
I
the
shall
samples
make
now.
half of this.
Is there any question that people want to ask there?
I think it's fine. I think it's okay at this moment. I'm going to send it to you if. Yeah. I'm good. Yeah. At this moment, it's fine. Thank you very much, Mr.
So what
Kesha.
time we meet you
Thank you.
tomorrow?
Tomorrow. Do you mind to wake you up at 6 a.m.? Is it too early?
6
Or
a.m.
7?
will be here, no
Yeah.
problem. Yes?
Thank you. 2 p.m. in this
In this lab.
Japanese time. Yeah.
Okay, we'll
Yeah.
be there 6 o'clock tomorrow morning. That's perfect.
Yeah. In the first experimental place.
Listen, Yukoko, what time is it now for you?
Now it's 7 o'clock in the evening.
And it's 12 o'clock here now.
Okay.
We've gone to summertime from today.
move to that's true. So it's a 7 hours difference now. So
Yeah. 2 o'clock,
yeah. So 8 o'clock in the morning to you.
7 o'clock our time is 2 o'clock your time.
Yeah. And then I shall meet you. I shall speak to you from the first experimental place.
When?
2 p.m. 7 a.m.
And what
For-
time are
in
you
you-
coming here?
You mean this place?
Yeah.
Yeah. In the morning. In the morning time to get the result.
Yeah, what time? When
I'm-
you are there, we want to be with you.
Okay. So I'm not sure. It's going to be another 3 a.m. or 4 because I coming back in the morning time. Are you
Okay,
really
we'll
sure?
be here 3 o'clock in the morning. It's worth it. We done all this work. We got to be there. So
Okay.
3 o'clock. What time is your time? What time is Tokyo time? Tomorrow you got to be there.
Tokyo time 10. Let's say 10.
10. So we go back 7 hours. Is 1, 2, 3, 4, 5, 6, 7. That is 2 o'clock.
Mr. Kesha, Mr. Kesha, I would like to make a sample now.
Yes,
because,
you do that. No problem.
Yeah.
But they have to
half-
make the other sample themselves, huh?
Yeah. So then I shall coming back with the result tomorrow. Let me confirm the time. 10 a.m.
10 your
Japanese
time, 10 Tokyo time will be online. It's 1,
Okay.
2, 3, 4, 5, 6, 7. 3 o'clock in the morning for us.
Okay.
We'll be here, and then we want to see. I want to see the results because if there is anything, I have to tell you what to do. Because
Okay.
those
Okay.
results are very important. There's no use leaving it half done. Okay? That's perfect.
Okay.
That's fantastic. Thank you very much. Yeah, we'll
Thank
talk.
you.
Is the guy with the skin problem there or not, or has he gone?
Yeah, there is. Yeah,
Can you ask
he's
him
still
to
working.
come? Can you ask him to come?
Yes. 博士。なんか、そちらをさせて。お肌の件で。Okay. He's coming now.
Hello. Hi. What I want to
He's been
do.
working for day for
Pardon?
So he's been working for us whole day for this measurement.
Yep, thank you very much. Say thank you to him. What I want to do, Yukoko, tomorrow after you finish the tests, the container of CO2 of the residual, no, the other one, the residual.
Those,
Yeah, from the one which is the material in it, CO2 material, not the drinking water. You put, you give half of that after the test. Yeah. You put half of that in a plastic bag and you give it to him. And you let him to put it on his wound. He shouldn't touch it. He just leave it there. You know, like with a bandage.
Yeah. You mean you're talking about CO2? This?
No, the other one in the container, not the drinking water. Yes, that one. Yeah, where is CO2? Not the drinking water. Where is the material? The gel.
This.
Yeah.
Gel is.
Yeah. You put quarter of this in a plastic bag. And you let him to put it on his skin.
Yeah. But it's okay. And then use the bandages to.
Just a bandage. Just keep it, and you keep in touch with him. And then we go to the next step. Okay.
Okay.
Don't take the CO2 you take out of this for him. Has to be in a plastic bag that it doesn't crack. The plastic bag has to be in touch with his skin.
Okay.
Yeah?
Okay. Yeah.
And then he just put a bandage on it and keep it a few days. Then we'll see how he progresses.
Okay, let me confirm. Only this jelly part, the sediment part.
Yeah, a quarter of it. Give him
it's
a quarter of it in the bag.
It's not absorbed, so it's not irradiated or anything. Yeah,
there is no radiation in it. You tested it, it's pure. Yeah? But it has the capacity to absorb the radiation from the skin.
Okay, I understand. So.
You understand? Okay, that's perfect. Thanks very much. Thank you, Yukoko.
Thank you very much.
Thank you very much. Bye-bye. Bye-bye.